Here is today's problem. The equation given is x squared minus 9x equals exactly 90. Our main goal today is to find all the values of x that work here. First, we look closely at the variables on the left side of the equation. We have an x squared term and also a linear x term right next to it. The constant number 90 sits completely by itself on the right side. Let us subtract 90 from both sides of the mathematical equation. This gives x squared minus 9x minus 90 equals exactly 0. Now we have a standard quadratic equation set equal to exactly 0. We have a coefficient of 1 in front of the leading x squared term. The coefficient for the linear x term is simply a negative 9. The constant term at the very end of the expression is a negative 90. We can use a substitution trick to remove the linear x term completely. This specific technique will make the equation much easier to handle. Let us define a new variable y to help us transform the entire equation. We will set x equal to y plus some unknown constant value we can call c. We want to choose a value for c that perfectly cancels out the middle term. The mathematical rule is to take exactly half of the linear term coefficient. Our linear coefficient is exactly negative 9 in this specific equation. Half of negative 9 is simply a negative 9 divided by the number 2. We flip the sign of this result to find our perfect required shift value. The negative of negative 9 halves becomes a positive 9 halves. So we will substitute y plus 9 halves for every single x that we see. This specific shift guarantees that the linear y term completely disappears. Let us write down the new expression with this exact substitution in place. We replace the first x with y plus the fraction 9 over 2 entirely. This entire binomial quantity must be squared just like the original x. Then we subtract 9 times the quantity y plus 9 over 2 as well. Finally, we subtract the constant 90 to keep the entire equation balanced. All of this algebraic expression is still set equal to 0 on the right side. Now we need to carefully expand the squared binomial term in our expression. The first term is y plus 9 halves all multiplied perfectly by itself. We multiply the first terms together to get a y squared right at the start. Then we multiply the outer terms to get 9 halves multiplied by y. The inner terms also multiply to give another 9 halves multiplied by y. We add these two identical middle terms together right now to simplify it. 9 halves plus 9 halves equals exactly 18 halves in total. 18 divided by 2 simplifies perfectly down to the whole number 9. So our combined middle term is just a positive 9 times the variable y. Notice how this perfectly matches the original linear coefficient number. Now we must multiply the last terms of the original binomial together. We multiply the fraction 9 halves by another identical 9 halves. The top numerators multiply together to give 9 multiplied by 9. 9 times 9 is equal to exactly 81 for the top part. The bottom denominators multiply to give 2 times 2, which is just 4. So the final constant from the squared binomial is exactly 81/4. The fully expanded first part is y squared plus 9y plus this fraction. Next, we must distribute the negative 9 into the second binomial group. We multiply negative 9 by the variable y to get a negative 9y. This negative 9y will nicely cancel with the positive 9y later on. Then we multiply negative 9 by the fraction positive 9 over 2. Negative 9 times positive 9 gives a negative 81 on the top. The denominator stays as a 2 because the 9 is just a whole number. So we get a negative 81 halves for this specific distributed term. Do not forget the negative 90 sitting completely by itself at the end. The whole long mathematical expression still remains entirely equal to 0. Let us carefully write out the entire expanded equation in one single line. We have y squared plus 9y plus the fraction 81 over 4. Then we have minus 9y minus 81 over 2 and finally minus 90. This whole massive sequence of algebraic terms is equal to exactly 0. Look very closely at the linear y terms in the middle of our long expression. We have a positive 9y and a negative 9y sitting right next to each other. These two linear terms completely cancel each other out just as we originally planned. This beautiful cancellation leaves us with no linear y terms anywhere in the equation. Our initial shift of positive 9 halves worked out absolutely flawlessly here. Now we just need to collect all the constant number terms together in one place. We have positive 81/4 and we have minus 81 halves. We also have the minus 90 at the very end of the expression to deal with. Let us combine the two fractions first before worrying about the 90 term. We absolutely need a common denominator to add these two fractions properly. The first denominator is a 4 and the second denominator is just a 2. we can simply multiply the top and bottom of the second fraction by 2. 81 times 2 is 162 for the new top numerator. 2 times 2 is exactly 4 for the new bottom common denominator. So we have 81 fourths minus 162 fourths right now. 81 minus 162 is exactly negative 81. This leaves us with negative 81 fourths from combining the fractions. The equation is now y squared minus 81 fourths minus 90 equals 0. We still have the negative 90 number that needs to be combined right now. We must convert 90 into a fraction with a matching denominator of exactly 4. We multiply 90 by the number 4 to get the correct new numerator value. 9 times 4 is 36, so 90 times 4 is 360. So the whole number 90 is precisely equal to 360 divided by 4. Our new equation has negative 81 fourths minus 360 fourths. Since both fractions are negative, we simply add their top numerical values together. 81 plus 360 equals exactly 441. So the constant terms combine to make negative 441 fourths. The whole entire equation simplifies down to y squared minus this massive fraction. We set y squared minus 441 over 4 equal to 0 once again. Now we can finally move the large fraction to the other side of the equal sign. We add 441 fourths to both sides of the mathematical equation. This simple move gives us y squared equals exactly 441 over 4. We desperately need to take the square root of both sides to find the value of y. When we take a square root, we must absolutely remember the plus or minus sign. So y is exactly equal to the positive or negative square root of our big fraction. We can take the square root of the top part and the bottom part completely separately. The square root of the bottom denominator 4 is simply the number 2. Now we desperately need the square root of 441. We already know that 20 squared is exactly equal to 400 flat. Our target number ends in a 1, so the square root might end in a 1 or a 9. Let us test 21 times 21 to see if it works out perfectly. 20 times 21 is 420 plus another 21. This addition makes exactly 441 just as we wanted. So the proper square root of the top numerator is exactly 21. This completely means our y values are positive and negative 21 halves. We are not quite finished yet because we desperately need to find the value for x. Remember our earlier substitution rule where x equals y plus 9 halves. We must now plug our two different y values back into this original formula. Let us start over with the positive y value of exactly 21 halves. We calculate our first x by adding 21 halves and positive 9 halves. The denominators are already the same, so we just easily add the top numbers. 21 plus 9 equals exactly 30 for the brand new top numerator. We simply divide 30 by 2 to get a final simplified answer of exactly 15. So our very first possible solution for x is the nice whole number 15. Now we absolutely must use the negative y value of negative 21 halves. We plug this negative value into our substitution formula to find the second x. We calculate x by taking negative 21 halves plus a positive 9 halves. Again, the denominators are identical so we can freely combine the numerators. Negative 21 plus 9 gives a calculated result of exactly negative 12. We divide negative 12 by 2 to get a final result of exactly negative 6. So our second possible valid solution for the variable x is negative 6. We must verify our derived answers by plugging them back into the problem. Let us carefully check the first solution where x is equal to exactly 15. The original math equation is x squared minus 9x equals exactly 90. We physically replace every single x in the equation with the number 15. This setup gives 15 squared minus 9 times 15 equals 90. First, we must precisely calculate the value of 15 raised to the second power. 15 multiplied by 15 is perfectly equal to 225. Next, we must manually calculate the value of 9 multiplied by 15. 9 times 10 is 90 and 9 times 5 is exactly 45. 90 plus 45 equals exactly 135 in total. Now we subtract 135 from 225. 225 minus 135 leaves exactly 90. So the entire left side mathematical expression simplifies perfectly to exactly 90. 90 definitely equals 90, so the very first solution works out perfectly well. Now we need to manually check the second solution where x equals negative 6. We replace the x variables in the original written problem with negative 6. This simply gives negative 6 squared minus 9 times a negative 6. We must be extremely careful with the negative signs in this part of the calculation. -6 multiplied by another -6 becomes a completely positive number. 6 times 6 is 36, so the first term is a fully positive 36. Now we closely look at the next part, which is -9 times -6. A negative number multiplied by a negative number always becomes totally positive. 9 multiplied by 6 is mathematically equal to exactly 54. So the second term simply becomes a positive 54 in our active equation. We must clearly add positive 36 and positive 54 completely together. Positive 36 and positive 54 perfectly add up to exactly 90. This cleanly means the total sum is perfectly equal to exactly 90 once again. The right side was also 90, so this second calculated solution is totally verified. Both of our explicitly derived roots perfectly satisfy the starting equation completely. We have successfully solved the entire math problem completely from start to finish. Thank you for thoroughly watching this complete mathematical demonstration today. Please easily leave a like and remember to quickly subscribe to the math channel.